Smith. I'm the SVP of product for the Bug Snag Group inside of SmartBear, and today I'm going to be talking about how you can elevate your game by using progressive delivery techniques. So before I get into that, I want to talk a little bit about my background and what we're going to be talking about today. So, as I said, I'm James Smith. Until very recently, I was the CEO and co-founder of a company called Bugsnag. And in April this year, we joined the SmartBear family, which is a leader in the testing space. And we now are part of a bigger family, helping teams solve quality and software health from end to end. I've been writing code for a long time. I've been writing code since I was in high school, and even dabbled in games. I wrote platform games. I wrote a 3D racing game, which I built for a bunch of platforms, including Linux at the time. And back in the early 2000s, it was very rare to find games for Linux, and it managed to get into a couple of publications, but it was awful. But I'm very much not a game developer. I'm more a well-rounded software developer, but I actually end up working with a lot of game development teams these days. And my previous company was also in the gaming space as well, but it was in the mobile gaming space. Haze App was a mobile social network for gamers. And outside of work, I spend a lot of time on Nintendo consoles. I've been involved in the portabilization scene, building really, really small Nintendo Wiis, the size of a Game Boy. And outside of that, really, I like to just play games casually. I am awful at Smash Brothers. You'd kick my butt. But I used to have a top 5 European score on Peach Beach on Mario Kart Double Dash. I'm sure people will kick my butt on that these days as well. So as I said, I run the Bug Snag Group at SmartBear. Bugsnag is a stability management platform. And what that means is we help you figure out which bugs you have in your application, how bad they are, which bugs to fix first. And the way that works is we detect exceptions and crashes automatically at runtime in production deployed environments. So once you've sent your game or your application to your customers, Bugsnag sits in the background and wakes up and detects when there's a crash or a bug, and then aggregates all those crashes by root cause. And we're in games that you've heard of, very, very popular in the mobile gaming space, but used across the board. And so if you've used any of these products, Bugsnag was behind the scenes helping you have a stable experience. And outside of the gaming space, we're actually pretty broadly used in every industry, but in particular, consumer mobile applications. Again, if you've got the Airbnb application on your phone, or if you go to airbnb.com, behind the scenes, Bugsnag is making sure that you're having a crash-free experience and reporting any bugs that we detect back up to the Airbnb dev teams. So what that means is I get to work with a lot of varied teams, a lot in the gaming space, and we see the trends that the consumer mobile companies and consumer companies are using, and help people understand, hey, is that something I should be using on the gaming space? But also learn from the gaming companies that we're working with as well. So let's set the scene. The world is very different to 10, 15 years ago. It used to be that you would spend a year plus on building your software, your game, multiple years in most cases. You would then print that gold master to DVD or Blu-ray, ship it, put it in a box, send it to Best Buy, send it to GameStop. And that was it. That was the game. It was done. You moved on to the next game. But there's been a bit of a trend recently. Pretty much every device, mobile devices obviously, but also now gaming consoles, are internet connected. There's pros and cons of this. The pros are that we can be more ambitious about the software and games that we write, and be responsive to problems that happen in production environments, in user-facing environments. If we find a bug that we didn't hot fix, we can patch it. You know, the obvious downsides of this, sometimes it's difficult to set that slider correctly. When is the right time to hit release and launch on a game? I won't name and shame, but there's been some recent examples of games that have been pressured to release too soon and launched a little bit buggy. One of the other downsides of this, of shipping frequently, is from the customer perspective. You end up having multi-gigabyte downloads happening. I play Call of Duty Warzone quite a bit with my co-founder Simon, and sometimes we're like, right, sit down, put the kids to bed, let's play some Warzone, and you have to do a 20 gig update. And so a lot of that is content, a lot of that is the new seasons kind of vibe that happens now in games, but pros and cons of this fluidity in releasing of games. So everyone's seen this. If you are a game developer, and it's true in any industry, not just the gaming industry, but the business teams want to ship the product as soon as it's ready. And maybe the business teams don't have that good an idea of what ready means. So there's a lot of pressure to build and launch very, very quickly. Also, there's a trend, and I mentioned this briefly earlier, of keeping content up to date. Most AAA games now, especially in the like first-person shooter space or the battle royale space, have moved to the seasons model. Or even like Rocket League, right? The games that are being launched once, but then refreshed and updated on a regular basis, sometimes multiple times per year. Season 1, Season 2, Season 3. You've got new characters, new content. It keeps your players and your customers engaged. And so stuff is changing in your code and in your content over time more frequently. And the kind of metrics that come out of that are now getting closer to the development teams. So the metrics of usage and ratings and engagement and all these kind of metrics aren't just things that the business and data teams care about anymore. It's metrics that the development teams should innately care about. So frequent releases are now the norm. Infrequent releases are being replaced with smaller, more frequent releases. So that Best Buy printed DVD is not happening. Releases are happening on a much more frequent basis. And in fact, we did a study on this. Now, of course, Bugsnag works across all of these different verticals and different industries. But what we found is most teams are releasing a new version of their software to their customers once a week on a weekly cadence. And gaming is no stranger. It's quite a big standard deviation on the gaming space. There are teams that are releasing as frequently as daily. There are teams that are still on the monthly model, but pretty much everyone that's using the Bugsnag product is releasing on a very frequent basis, with weekly being the median, being the norm. So obviously this comes with downsides. I mentioned a couple of these before, but you're shipping more frequently, you're changing your code and your content more frequently. There's less time for QA. There's more room for bugs to sneak in. And if you make a big change, roll it out to your customers, it could be that a bug affects everybody and everybody gets screwed by that. You do not want that to happen. I talk about rage quitting here, but if you have a bug that brings down your server, if you have a bug that means that no one can do in-app purchases, it's going to get out there. It's going to, especially in the gaming space, there's a lot of, let's just say, high expectations in the gaming space and a lot of visibility and eyeballs on the products. So if a bug brings down your in-game microtransactions for a day, that's going in the news. People will hear about it and it's going to harm the brand. So how are we solving these challenging competing dynamics? What a lot of people are doing are moving to what is now known as progressive delivery. And this allows you a modern approach to developing, testing, and deploying code and content to your customers without those risks. Introduces some different risks, but without those risks that we said earlier of a big bang release that screws over your whole customer base. So what progressive delivery kind of means is that you can deploy changes quickly. You can manage the risk around those deploys. You can then make data-driven release decisions around these releases and how broadly you want to roll them out. And you can focus on the user experience all the way through to the production environment, including 100% rollout. So there's kind of three different maturity levels, I would say, of progressive delivery. Probably everyone watching this is certainly using level 1, or if not, you probably should be. And then there's additional maturity levels on top of that. So let's start with level 1, which is phased rollouts. Now, phased rollouts take many forms. I think the one that's most familiar to people is a beta rollout, for example, or an internal alpha. The idea behind this is you're not giving your new version of your application to everyone at once. There are other ways to do this as well. For example, you can put a bunch of features, let's say there's 5 new features, into version 2.0 of your game. And then you can use tools in various distribution channels to give that version to your customer base at a ramping pace. So the classic one here is, start with developers, then move to developers and beta users, and then move to some early adopters, and then move to everybody in production. What we found is, if you're making mobile games, for example, both the Google Play Store and the Apple Store now have built-in mechanics in their release dashboards for developers to say, only give this out to X% of my customer base. So it's a single code base, but you can say, I've cut a new version, only give this version to a subset of my code base. So betas, hopefully everybody's using, but there's layers on top of it even in this approach, including phased rollout as a percentage of your customer base. So check that out. That's something worth doing. Most of our customers in the gaming space that are doing very frequent releases are doing that approach. And, Zynga is one of our customers, and they're one of the people who've been doing this for a really, really long time. Built their own phase rollout system, built their own A/B test and experiment system, very, very data-driven. And I'll talk more about some of these later on today. And so they're definitely seen as leaders in this space. So that's level 1 covered. Do your beta test, do your internal distribution. That's probably everybody's doing that already. But then look at your distribution channel. If it's the mobile application, look at the Play Store, the Apple iTunes Store, and look at the settings in there. You can do phased rollouts of new versions. Now, when we go up to the next level, we're talking about a non-homogeneous code base. Now we're talking about having your code change, but turning on and off chunks of that code depending on the customers that are using it. So what do I mean by that? So this can be used for new features, new content, and all sorts of things. So feature flags, experiment systems, and A/B testing systems allow you to release a new version of your code, but have a dark release. Now, dark release means that the code is there, but it's not active and it's not live. And I think a lot of teams have adopted this, but if not, actually it's getting really, really easy to adopt this. You can use products like Launch Darkly or Split, which are the two leading feature management solutions that allow you to turn on and off chunks of your code base or content based on feature flags. A lot of people historically did a homegrown system using some kind of remote Redis flagging. But the idea is that you can now use an off-the-shelf solution to make this super easy. So what do I mean by turning on and off parts of your code base or content? Well, there was, I'll talk more about this a little bit later, but there's been some big bugs and outages recently that happened at the operating system level. If you wrap code that interacts with these services or wrap your new feature, you can remotely turn that on and off using these feature flagging systems. So let's say that an example of a content rollout here is it's a bit out of date now, but the Travis Scott event in Fortnite. Now, it's unlikely. I don't know. I'm not on the team, the Fortnite team, but it's unlikely that this Travis Scott event was streamed to everyone. Right? The actual content. This is probably pre-recorded. All of the 3D models and the events that were triggered in the engine were obviously built in ahead of time in advance, and so likely what Epic did and the Fortnite team did is they built this into the application. So when you get a new update in the app, you're like, okay, new update, there's some update my version of Fortnite. Oh, I didn't see anything new, or maybe I saw some stuff new, but I didn't see certainly giant Travis Scott showing up in my game. And then at a certain point in time, maybe it's triggered by a remote feature flag or a timer or something like that. This content is unlocked. The content is turned on. And you can do that for things like content. You can do that for things like new features, seasons of games. And it allows you to turn things on and off. The off part is very important as well. And I'll talk more about that in a minute. A/B testing is another form of this. This allows you to run multiple concurrent versions of something to see which one's performing better. And again, this has been around for a while. Zynga really pioneered this in the mobile space a long time ago, but it's really been around for as long as I can remember. This allows you to say, the trivial example is I've got a red button and a blue button on my purchase screen. Which one performs better? But also you can do things like changing pricing dynamically in A/B test cohorts, or you can A/B test features. So you can turn on a huge swathes of a code base based on a feature flag and then measure the performance of that feature or an overall product metric. For example, you might be trying to increase the engagement of your product. You want people to come back every single day. So in one A/B test cohort, you might say, let's make a new, give the player an in-game currency every time they come back every day. And then you can measure if that A/B test cohort came back more frequently and increased engagement, for example. And again, this is something that has been around for a while, but it gets a lot easier these days with these off-the-shelf tools. So running experiments is fine. You need something else on that as well. You need to figure out if those experiments are working. Either are they giving me an improvement in my metrics that I care about, or are they crashing or breaking the application or making my application become less performant? So I'll give you an example here. One of our customers, our large customers, uses a lot of A/B tests and experiments. And they did a phased rollout. They saw bugs inside of Bugsnag, and they were able to then roll back that experiment to make sure that it only impacted a few people. This was a new feature that ended up only impacting 121 users, and this has got an application that has tens of millions of users. Once you've got A/B tests and experiments in place, using products like Bugsnag or using metrics measurement like in Split, for example, allow you to figure out, is this phased rollout healthy or not? So this is a good example of where one of our customers rolled out an experiment that had crashes in it, spotted those crashes inside of Bugsnag, and then were able to roll those back. I'll talk more about that now. This is the highest maturity level is observability and monitoring. Probably most of you watching this are using some kind of observability and monitoring to some level of maturity. Worst case scenario, you've got some logs that you're looking at. Worst case scenario, you've got some analytics that are saying, here's our revenue and here's the number of customers using our product per day. If you're using phase rollouts, experiments, feature flags, A/B testing, you can take that to a whole new level of granularity. And I recommend that you do this because it allows you to be really data-driven about when and how you make releases in your software. So observability and monitoring help you understand if new code or content changes are working the way that you expected them to work. And so there's a couple of dynamics there. I said one of them is usage and metrics. We rolled out this new feature to help with engagement. Did engagement go up? Otherwise, how can you know if it was worth building that feature in the first place? I think most teams are doing something like that. But also, you can do that for issues. You want to make sure I've rolled out this new feature. Is it crashing? Is it impacting performance? Are there any issues that are impacting stability? And doing that at a granular level is really important because it allows you to roll back. Now you're using something like experiments and feature flagging. You can turn on and off things based on a remote flag. So you screw something up or there's a third party screw up, you can now turn those feature flags off immediately. Now, here's a really good example of that. Let's say I've got two pictures up here. Let's say that you changed the design of the application to make the download and buy now buttons red instead of transparent. And you thought, great, they're red, they're more visible, people will buy more of our product. Well, what if actually in reality, now they look like error buttons or error states and your customers were afraid to click them? That could tank your revenue. If you're tracking these metrics, you can now turn them off immediately. A really good example of bugs and crashes, and any Android developers watching this will be cringing now because probably you're just recovering from this whole outage. But a few months ago, there was an update that was an operating system level update where Google updated the WebView component, and that caused any app that linked to the WebView component to crash on boot. And that's an absolute nightmare as a developer because something happened that was nothing to do with you and nothing to do with your changes that caused your application to crash. But you can be defensive. You can do defensive programming and wrap all third-party services and API calls, if they are non-essential, in feature flags. And then you can turn on and off these features if there's an issue. This is another way of doing defensive programming. You don't necessarily have to have some kind of fallback if you detect an outage, but if there's something really bad going on, you can turn these things off. And a lot of our customers, in fact, did this for the Facebook outage last year. There was a huge Facebook SDK outage. Any application that had Facebook authentication had a failed API request to the Facebook server on boot and caused the application to crash. Some of our most sophisticated customers wrapped the initialization of the Facebook SDK in their iOS applications, which was a platform that crashed, and then were able to disable the Facebook SDK remotely, and then fell back to a message that said, hey, Facebook's not available right now. Try logging in via email or come back later on. So you can turn things off based on the signal that you get. So, in summary here, one big takeaway I think I want people to have in the bugs world of this and the stability side of things is, look, shipping quicker allows you to give value to your customers quicker. There are downsides in that you might introduce issues, bugs, and problems. But maybe that's okay because not every bug is worth fixing immediately. Most dev teams are stretched really thin. What if you could say, let's fix the bug that's impacting all of our customers that's on the payments page, rather than the bug that's in some obscure settings page that maybe nobody really goes to? You can then prioritize the bugs or decide if bugs are even worth fixing or not. On the mobile world, a lot of people will jailbreak their iOS or Android phones. Maybe you don't want to fix the bugs that are caused by jailbreaks. You might want to fix them, but if you don't want to, great, you don't need to fix those bugs. Shipping faster means you can reduce QA time, you can get features out to your customers sooner. If you have that visibility into production environments using Bugsnag, using analytics tool, using an A/B testing experiment platform, it allows you to ship faster, reduce the risk, and then have data-driven decisions around which bugs to fix first. So you can do that with progressive delivery. You can do that with the Bugsnag and measurement monitoring layers on top of that. Get that observability layer on top. And then you can ship faster. You can get stuff to your customers who really want to see it quickly without pissing them off by having a huge outage. So Bugsnag is proud to sponsor GDC this year. We've got a booth, virtual booth. Come and join our booth. Come and get some swag. Come and talk to our team, and we can help you figure out, hey, here's our recommendation on progressive delivery systems, or we can help you get set up with Bugsnag trial and learn more about how existing Bugsnag customers are using the product. And hey, come and pick up a t-shirt while you're there. So thank you so much for watching. Appreciate it. And I'll stick around in chat for questions.